Hello there and welcome to this course on data wrangling with R. My name is Valentine and I'll be your instructor. This course will follow the following structure. So we'll get started with the learning outcomes. After that, we'll get to learn about what data wrangling entails. What are those fundamental concepts that we need to take into account when it comes to performing data wrangling. We'll also talk about why we perform those techniques as well as when we actually perform them. After that, we'll go through some in-depth reading that we have created. We will give you this reading and as well as a quiz. So the idea is that you will be in a position to have gone through those concepts that we'll have talked a bit earlier on with regards to data wrangling, but now in an in-depth way. Once you finish the reading, you'll also be required to just go through this quiz to just check your understanding of those important concepts. Once you've completed both the reading and the quiz, the next step will involve just going through the practice work, which will generally entail going through some practice work that we've already curated that contains examples for each and every concept that we'll go through with regards to data wrangling. And the idea is that you're going to put, again, those concepts that you'll have learned theoretically now into practice. Then towards the very end of the workshop or the course at the end, we'll have a project that we'll give you that will allow you to put into practice again what you'll have learned during the practice session, as well as the overview section in a real world context. And the hope is that you'll have achieved those learning outcomes by the end of the course that we'll have set out to have achieved from the very beginning. So let's get started with this course. Starting off, what are our learning outcomes? By the end of today, we are expected to have achieved these learning outcomes. We should be able to apply data exploration techniques to understand the structure of a data set. We should be able to outline the techniques required to transform data into tidy data that is usable for either visualization, for even further analysis, such as machine learning, creation of machine learning models, or the creation of dashboards or reports. We should also be able to apply data wrangling techniques using what are called R-based functions, as well as tidyverse packages to manipulate and analyze data. The tidyverse packages are just generally commonly used packages when it comes to working with R that allow you to perform any sort of data analysis work that you might have in mind. So yeah, so those are the learning outcomes. So once you finish this course, you could always just revisit these ones to just check whether you had achieved what you were meant to have achieved. Starting off, what is data wrangling? So data wrangling generally entails that step during a data science workflow, even a data analysis workflow, that makes the collected data useful for further analysis, such as creating descriptive analysis reports or modeling. That's machine learning. So on the far right, you see a diagram. If I just move it closer, you can see that it's a diagram that has just different stages. CRISP-DM generally is, just a second, CRISP-DM is a methodology, a project methodology that data scientists or data analysts normally use when it comes to working on data science related projects or data analysis related projects. And it normally starts with business understanding, then later data understanding, data preparation, modeling, evaluation, back to business understanding, or go on or to deployment. The idea generally would be that when you get a project, first of all, you'd understand the business aspects or the organization aspects, like what are those objectives that an organization is looking towards achieving with the data science tools or solution that you would end up creating. So that is usually the first phase. Once that is done, the next thing is just to look for data, source the data that you need in order to answer some research question or business question that you have. And once you've gotten a source for that data, you then import it, understand it, then prepare it. So Generally, data wrangling involves these first two stages, some elements of these first two stages of data understanding and data preparation. It might involve performing just data exploration techniques like being able to sample records from a data set in order to understand the structure of the data set, or being able to create a summary statistics, get some summary statistics information about the data set in order to understand some in-depth aspects about the data, maybe to check whether they're missing values, or to check even whether they're outliers or duplicates. So that's what data wrangling would entail. And that's what we're going to be performing. There's this concept of tidy data that was introduced by Hartley Wickman that talks about the goal of data wrangling is having each observation in a row. That is if you're working with data that's in a tabular format. Also having each variable in a column, and also having each value in its own cell. So if you have data where you have probably multiple rows within maybe one particular cell, something of that sort, then in such a situation, data isn't tidy. And the objective is always just to ensure that your data is in this format. And when you look on the other side in terms of characteristics of tidy data would entail data that probably does not necessarily have column headers. In that situation, you would need to ensure that you look for those column headers, and or you assign appropriate column headers to just each and every variable name or column. Maybe if you have multiple variables stored in one column, maybe you have region, and region has city, and it also has country. You might want to split that in order to, let's say, perform some research afterwards. But of course, that again depends with the research question that you are working towards. You could also have variables being stored in both rows and columns. You could also have multiple types of observational units, maybe stored in the same table. Maybe if it could be users data as well as maybe orders data within one table. You might want to ensure that you've split those observational units differently in order to work with data in an easier way. And also maybe in terms of also having a single observation stored in multiple tables. Maybe you have users information, maybe records stored in one table and another table. You also have the same information that you might want to figure out a way of merging that data and being able to making it organized in a way that you can perform just generally in a data analysis with ease. So there are different data wrangling techniques that we'll come across. These are the ones that we are going to be working towards. They're most commonly used when it comes to data analysis projects. There are of course others, but these are the most basic ones that would allow you to be able to work on any sort of data analysis or data science project that you might come across. So data wrangling techniques in terms of importing, learning about different importing techniques, whether it's importing from CSV data, from Excel data. So that's something that we'll go through. There's data understanding, being able to explore the first maybe few records, the last few records, understanding how many records there are in a data set, how many columns there are, what are the data types. That is something we are going to go through. Standardization, ensuring that the column names are uniform, in the sense that you could have lowercase characters as part of what make up the column names, instead of having just different column names having maybe capital letters, such. The same case with the ensuring that your data does not probably have trailing spaces or leading spaces, or space that may not may actually somehow make that data hard to work with. There's handling irrelevant data. There's also handling duplicates, handling missing data, handling outliers, as well as merging data sets. So those are just the techniques that we'll go through using R in a few, and we'll get to see how to go about it. But in order to get to implement these particular tools, we could write R code, like basic R code from scratch, but already there have been libraries, or in the context of R, which are called packages, that we can be able to use in order to perform the data wrangling techniques that we can, that we're going to perform. There are what are called R-based functions, which are provided by default with R. There also is tidyverse packages. So tidyverse packages are a collection of packages that we can be able to use to perform data wrangling. There's dplyr for normally performing data manipulation and analysis. There's tidyr, just cleaning a bit. It provides us with just a few things that we can use. I think a few functions that we can, actually not a few, quite a number of functions we can use for data cleaning. There's readr that we can use to import data with. There's ggplot that we can use to visualize data, especially when it comes to visualizing data such as outliers. Then ggplot can come in really handy. This is just a quick example of just R code. I won't go so much into this. The first two are comments, but this is what is just R code. In our situation over here, we're performing some sort of filtering for the records in this particular data set, where the column length, SIPO length is greater than 5, and storing the outcome in selected DF, and then later selecting these columns, SIPO length and SIPO width, from selected DF, which is what we had here, using the select function, and that will just display for us those records. The second method is just another method for implementing the same operation, where we filter. We first of all reference the table, the tabular structure that we're using. That's a data frame iris df, and then we apply a filter operation to iris df, where the SIPO length column is greater than 5, so we would end up getting all records that have SIPO length greater than 5, and then we define to select only these two columns, not the first, but we define to select these two columns. And yeah, so there are quite a large number of companies as well that are using R. If you go through this link, you will find that there are quite a large number of companies, and this should give you generally a good idea of. Let me even just reshare it in a different screen, because I think it's not clear on that. Just to give you a good idea of companies that are using R. So these are just a few companies, as well as projects that one can use in order to just get some inspiration for how, or for where you can apply R. And yeah, so those are just a few companies which you might find. So I think that should be good. Okay, all right. So now going back to our, I think just a minute. Let me scroll back to. Okay. Yeah, I think that's basically it so far in terms of what we expected to have understood in terms of R generally. The next thing that we're going to go through is now the reading and the quiz that we had earlier mentioned that we will give you. So we've also provided this. Just go through this reading and then cover this quiz. Once you have done that, you should have some good foundation, theoretical foundation of what data wrangling entails with regards to R, and then we're going to get started with the practice work. All right, once you've gone through now the reading and the quiz, probably taking a bit of some time, maybe 5 to 10 minutes. The next thing that we're going to do is now to go through the practice work for this particular session. And to be able to do that, we are going to go to to get started with working with R. There are two options that we can have, but for this particular option, it's the easiest one that we can use to learn R. The first option is usually to install what is called RStudio locally. So RStudio is a integrated development environment that's provided by RStudio and or a company called Posit, and that allows us to be able to install a software in your computer and be able to write code and organize projects with in relation to R. that's the first method that we can use. We can first of all, actually, the option is usually you've used that method to install. The first thing that you do, install the R programming language, then later you install R Studio, which is the integrated development environment. The second option, which we are going to be using, is to use what is called POSIT Cloud. POSIT Cloud is a tool that we can be able to use for generally it's more like a the R Studio version, but now on the web, and that's what we are going to be using. So I'll ask you to visit this link, posit.cloud. The company behind R Studio also have this cloud solution that you can use that just creates an instance or a copy of R Studio, but now it's just a web application that we can be able to work with. That this particular option will just help you to just avoid maybe installation issues, which may not necessarily be part of, which are actually not part of what we cover in this particular course. The idea is not to help you resolve those challenges. The idea is to help you just learn. So I'll ask you to visit this particular link, POSIT Cloud. Once you've visited it, just sign up for a free account. The free plan, they have a free plan, and can sign in with Google. And once you have been able to sign up, you should end up to this page. Once you've logged in, you should end up to this particular page. Once you've gotten here, the next thing that you need to do is to go to new project at the very top, and then click on new R Studio project. And that should redirect you to another page. At the very top, you see untitled project. Just click on there and update that with the name that you want. Let's say data wrangling with R, and press enter. That will be the name of the project, and then R Studio will be loaded shortly within your page, and voila, this is what we have. We have R Studio, which is just much more similar to what we have locally. Once we have done that, the next thing that we need to do is to upload the practice notebook that we have shared. So there's a a practice workbook. Actually, it's this one. So just click on it, download. Just say download. Actually, the format of this file is an R Markdown file. So download that, and we need to upload that. But you'll need to download that, as well as also this other one called Solution One, the Solution Workbook or Notebook. Download it. You can call it Notebook. I'll update the names to Solution Workbook, just for ease of understanding. So download that. So I think you've downloaded both of them. So we need to upload them into POSIT Cloud so that we can start, or the R Studio on the web version, so that we can be able to start, and we'll upload them from this particular section at the bottom section. So we will click on upload and then choose file, and then you can choose both files. You can choose one file at a time and say open, then okay, and it's going to upload the first one. It's written R practice notebook. Then you can also upload the next one, solution. Just note that here I've written them as practice notebook and solution notebook. I'll update them later. So once you have uploaded them, you just click on the first one, practice notebook, and then it will pop up another window on the top left. This is the editor. This is where we can be able to write our code and be able to execute it. The very bottom, you have a console, terminal, and backgrounds job tabs, and these ones will just allow us to be able to interact with the system where R Studio has been installed. So we can also run our R commands here, or just different R code here as well. We can also interact with our system. For instance, if we wanted to run Linux commands, to make new directories, as opposed to just using the graphical user interface. So the terminal here is just for you can interact with the system that you see on the file system that you see on this other side, still using the terminal. Like, for example, if I want to see which files are in here, which are actually two, these ones are hidden. Actually there are three. This one is hidden, so there are three files. If I want to preview them using just the terminal, I can say ls, and I should be able to see the different files. So these are three files which are here. Now you can also make a new directory, etc., using just the terminal. Background jobs will just tell us what's happening behind the scenes whenever we install something. On the top right, we have environment tab that will just give us just the variable values. Whenever we create new variables, we will just be able to see them here. There's a history tab, there's connections, there's tutorial as well. At the bottom, you have files, packages, plots, packages, tabs, but this one is the most important that we're going to use. All right, so once you've gotten there, the first thing that you need to do, once you've clicked on Practice Notebook and this has shown up, it will ask you to install R Markdown, which we need, and tidyverse, because this notebook tends to use that, so we can just install that. This are not notebook, it's just a workbook. So once you click on install, you'll see something behind the scenes happening in the background jobs. But to just ensure that we're able to get some good space of that, we can just click on minimize here. And we should have some good space over here. And you can also drag this to the right a bit, so that you're able to do something about it, but to just get some more space. But something else to note is that if you want also to, this is the practice notebook. So if we want to view also the solution notebook, you just click on it and then it's going to open in a new tab inside the editor. Yeah, so I think this one has finished. You can just minimize it, and also you can install that, but it's already installed. There's no need for that. So you can be able to just move around the different tabs, because the solution workbook here has solutions to the challenges in here. So just to be on the same page to help you in that. All right, so once you have done that, the next thing that you need to do is to now visualize. You could also visualize now. What we have here is just R code, and it has been written in a language called Markdown. And what's actually enclosed here is R code in these 3 delimiter set of delimiter characters, actually R code. The same case in the solution notebook, but to preview it in an easier way, we are previewing the source. We can just click on visual. It's going to prompt us that we want to use visual mode, which it should in a few seconds, and just say use visual mode. And this is a bit more clearer and much more easy to work with. This is what we are going to be working with. You can also do the same thing for the solution workbook as well. So then we'll get started. All right, so installing the packages, that's the first thing that we're going to do. And generally, we're going to be installing tidyverse, which is a again, collection of packages in R packages that we can use for data manipulation, analysis, cleaning data, importing data, etc. So let's install them by simply going to this particular section of the notebook. This is R code that we're going to run, and we're going to install it by just clicking on that icon at the very top right. And that should happen. Once that has happened, we can load the tidyverse package as shown. We had also done this a bit earlier. So when we were asked to install R Markdown or tidyverse, we had already installed them in our environment. But now, once we have installed them again here, we don't have to, but we could always just do that, but it's okay. We can then load them in order to use them. So when it comes to working with packages, we need to load them in order to use them. So let's do that. We're going to load all those packages, which you can see here. Then moving on, don't ignore just this conflict. Don't worry so much about this conflict. Moving on, data importation. Let's minimize that. Data importation. So that's the first section, how to import a data set. So when we want to use data to answer a research question, we first of all source the data set and then import it. For our case over here, we're going to first of all load a CSV file that's stored somewhere on the web. We'll learn how to also download the dataset a bit later, or upload the dataset into this environment, maybe any custom dataset that you might have. So starting off, to be able to load or import a dataset, a CSV dataset from a URL, we use the read.csv function. And inside the parentheses of that function, we define our location, which is what you have here. And then we store that inside citiesdf, and all of that. And citiesdf is just a variable, so we store our dataset inside this variable. That's it, and we preview that data. Well, when the variable, you can also refer to it as a data frame, because it now is a tabular structure. Actually, a data frame is a tabular structure with just rows and columns, and we preview it by just referencing or calling that data frame is shown here. So this is what we have, and they're printed out in chunks of about 10 records, so you can preview as many records as possible. So that's the first method. If we had this file stored in a URL somewhere, we use read.csv. We can also decide to upload our file. So the first thing that we do is to download the file. So you can copy this, or you could press just copy it. Just copy this link, copy, then paste it in a new tab. It should download. You should see it downloading it on the top right. So once that is downloaded in your downloads folder, you just need to upload it. You'll upload it just like how we uploaded the files that we did. So we need to go to upload, then upload the file, the CSV file. Then you should see cities.csv, and okay, and then it should show up inside your location cities.csv here, the file section. And then in order to read it, we can just pass the name of the file, which is cities.csv, into our read.csv function, just like we did with the URL, but now we just name it here. Ensure that the name that you have here is similar to what is here. And then we just repeat the same process, and we can run that, and we can be able to see the records. Additionally, when we are reading a data set initially, we might have a data set that possibly does not have some good structure that would be okay. So for instance, if I remove this part, assuming this is the data set that we loaded and it saved it in df2, if I run this, you note that this particular data set doesn't look, it doesn't distinguish between the different columns easily. What's displayed doesn't give you just straightforward columns. And you can note the records are separated. For the records for the columns, for each column are separated by a semicolon. So in order to read this data set and have it in a tabular structure, so you can define what is called a separator, which is actually what we have here. And we can define that our separator, when we are reading for this particular data set, is a semicolon. So that's what I had removed. So we use as a second, it's called a parameter. So the first parameter that we gave to this function was the dataset link. The second parameter, which comes after a comma, would be SEP, separator, step is equals to, then in quotes, the separator that we have. If it was a double colon, we would have done the same thing, but now here we're just using a semicolon, and let's run that. And then we're good to go. You can see the actual data set now loaded, and then we can perform further analysis if you want. All right, at this particular point, I would like to ask you to work on the challenges. These challenges, then once you have gone through them, verify them with the solutions in the solution notebook, and then we can continue. Moving on, the examples. For the second part, the other part now, the third section of this notebook, data understanding. So by the way, you can pause the video so that you work on those challenges. Once you're good, you can continue. Just ensure that you work on the challenges so that you're able to challenge yourself and be able to learn those skills. So assuming that we wanted to preview only some few records of the data sets, instead of displaying the entire data frame as we did here or here, what we can do is we can decide to preview maybe the first 6 records, and we use the head function, as you can see here. So if I run this, I should be able to see the first 6 records of that particular data from the cities one. The cities one was this data set here. So we use just the head function. But if you want the head function for 6 records, if you wanted to preview maybe more than 6 records, we can do so by defining the number of records that we want. Let's say we want 10 records, we use head, but the second parameter would be the integer, which would be the number of records that we want to preview. Run that, and you should be able to see 10 records here. We have 10. Right, moving on, assuming we wanted to see the last 5 or the last 6 records. Here we are seeing the first, using the head method or the head function to preview the first records, but we can preview the last records by simply using the tail function. So cities df, as you can see here, we run, when we pass cities df inside tail function, we get what you see here. We can also preview, not only that, we can also preview the number of records that we want by specifying the records that we want. So we do that by adding another parameter, the second parameter, as you can see there. str cities, sometimes we might want to display maybe data types, also the first few columns or the columns that we have in a data set. Then we can use str function to be able just to get some good idea about the data set characteristics, and we can use str. And we have the columns, which of course make up that data set, and also we have the data types. Data types are just classifications that we give to a data set, and we have character data type, number data type, but also we have an idea of how many records we have. We have 213 records in the cities data frame, and as well as 5 columns. And also these are just a few, the ones that you see here are just a few records for a few records, the first few records for actually 6 records for 6 or 5 or 4, just a few, actually not all, for that particular respective column that we're working with, because here we have 4, here we have 4, here we have 5, here we have 5 as well. Right, moving on, sometimes we might want to preview an unbiased number of dataset records. So if we don't want to preview the last 5 or the last 6 or the first 5 or 6, because those might not necessarily tell us the entire story, we can preview a sample. A sample could be any record that has been selected randomly from the dataset, and we use the sample n function, which is provided by dplayer, and we can be able to preview the first 10 records as shown. To be able to also quickly check the size of a dataset without maybe displaying additional information, such as maybe just checking the number of records as well as the number of columns of variables, we can be able to use the dim function, and we pass the data frame name, as you can see. And here we have 213 records and 5 columns of 5 variables. At this point, work on the challenges, and then once you have done that, then verify them with the solution notebook, and then we can continue the solution workbook if you want. Okay, moving on. Performing standardization. Sometimes we might want to ensure that our data set is easy to work with by ensuring that the data that we are going to be using to reference the respective maybe part of the data set is uniform, is in a form that is easily easy to work with. So we might want to ensure that the column names are in a preferable format that we can use to reference later. So for instance, we could decide to lowercase all the column names, to have all the column names have lowercase characters. That way it's just easier to work with. So starting off, let's first of all preview the names of the dataset in this other dataset. That's df2. Let's preview that. And this is what we have. We can update the existing column names. Now, these are the column names that we have, but we can replace these ones manually by simply, because we use this code to be able to get those records, to get those column names. We can still use the same thing, but we say that we want to replace now these existing column names with new ones. And we would normally use what is called a vector. A vector would contain data types, similar data types, but generally we can use a vector to be able to define the items that we want inside the new column names generally. So we use a C, then inside the parentheses of that we just define the names, the column names, and then we store that in we replace what we have here, the new column names, with the original ones, and we preview now the new column names. So if we run this, we should be able to get now new column names which have a proper format, a format that works well for us, which is what you can see here. All right, so moving on. So something else that you might have noted is that we have not applicable because we did not replace total account. We did not replace account B, and also we did not also replace this particular total account. And the replacement here actually has an issue because the replacement happens with the order of these particular column names that we have. So the total account actually replaces account A, doesn't replace total account here. So that is something to note. But this is just the idea is just to know that you can be able to use this method to replace column names with whatever that you want. Alternatively, we will get to learn a better method of doing this. This is hard coding method, but we'll get to see how we can apply an entire function to all column names. That might ensure that you don't get into issues such as what we have gotten into here. More on, we might also want to ensure that our columns or even just our column names don't have trailing or leading spaces. Sometimes you could have some spaces before or before here, after, which when would interrupt how would bring problems when we want to reference a column. Because if you try, let's say, to reference maybe height, and you are trying to reference height, you might not know why you're not getting the height values, and the reason could be there are spaces before and after. So how we can be able to remove those leading spaces and trailing, these are spaces before and spaces after the column names, we can be able to use the trim_mws function. So here we just load our data set, and then later onwards we can be able to use the trim_ws function to be able to replace the column name. So here we are referencing the column names that belong to df2, and then we, as a second parameter, we use we set which parameter to equal to both to specify that we want to remove leading and trailing spaces. To run that, you should be able to see now our new columns don't have leading or trailing spaces. Alternatively, by the way, we reloaded this so that we have new column names. We are not working with these ones. Alternatively, we can decide to apply. So this is the other method for lowercasing the column names. So we can be able to use the toLower function for that. So names, then df2 would be what we have here, and we get the we actually get the column names for df2, and we apply toLower function to be able to apply the operation to the column names, and then we replace the original ones and display now the new ones. Work on the challenges, and then once you're done, let's continue. Handling irrelevant data. If we are working with some research questions that do not require the use of all the columns that we have in our data set, then we can decide to drop certain columns. That operation that refers to dropping in when it comes to working with maybe R, when it comes to applying that operation R, we normally would only specify the column names that we don't want out of the entire data frame by simply using this method. So first of all, we use the select function, which will just generally select the column names that we want. But at the same time, we say df2, select df2, and then we put a minus, which will be just a minus operator to define the columns that we don't want, and then we specify the column names that we don't want. Alternatively, if you want those columns, you can just simply leave that as it is. But yeah, so that's just one of those methods that we can be able to use to be able to define the columns that we don't want to select. So then we preview the first six records for df2. All right, work on the challenges, and when you're done, we can continue. Finding and dealing with duplicates. So we're going to use a different data set in this case. So let's load this data set. It's an NBA data set that contains information about NBA players. So you'll see here. Then we can also see how many records there are. 458.9. Now, starting on, if you want to get the duplicate records from a data frame, we can be able to use the duplicated function. First of all, we define the data frame that we want to apply that operation, and we specify square brackets. And inside it, we use a duplicated function to be able to define the records that we want to check whether they are duplicated, comma. What we have here is just defining we don't want any columns. We don't want to check for columns. What we are applying is this particular function to the rows column, and to the rows, not column, to just the rows. And then we specify the NBA records that we want to check for duplication for. So it's NBA DF. So if we run this, we should be able to get the columns that are duplicates. But again, in this case, we don't. If we don't want to extract records which are not duplicates, we can just simply put an exclamation mark or negation character in front of the duplicated function. And alternatively, you could also use the unique function to be able to get the unique records within the data set. So I can even just comment that. Let's run this to be able to. So here we have, okay, we can even just decide to have this dupe. We can even just have a variable and then dupe, so that we're able to see what's happening here. So these are records which are not duplicates. These are records which are not duplicates, the unique ones. So we use the negation here, but here we would have also done, no, this one not dupe, not, let me just not dupe. I can just do an underscore dot, not dupe, not dupe. These are not duplicates, these are the unique ones. We can also use this other method. If I run this, I should be able to get the same thing. 458.9 records. Then here I can also say dupe, dupe, which we don't have. Okay. So alternatively, we could also define duplication based on certain columns that we have. So if certain columns have multiple values that are similar, so if we just want to get the records that are unique based on a certain column, we can define the column as shown here. We still use the same method as we had used here, only that when we are defining NBA DF, we want to define a specific column. So we use a pound sign and BA, then pound sign, then specify the column that we want to use. And we can also say col. These are the unique values actually. Let's remove, these are the I'll just not dupe, not dupe, no dupe, no dupe. These are not duplicates, but if I want the duplicates, I remove the exclamation or the negation mark. And these are now the duplicates based on the team. But this may not necessarily be important in this particular case or for many research questions. Right, work on the challenges and then we continue with this missing data. To work with missing data, we're just going to create a dummy data set that will help us to be able to work with missing data. So the first thing that we can do is simply let's create just a data frame that we can be able to use. That's a tabular structure that will contain some data. This is just one particular column. This is another column. This is another column. And we use the data frame function, data.frame function to be able to create that tabular structure. And we display it as shown. So we have name, sex, age. So we have missing value there and a missing value here. So if we want, we can use the isNA function to identify missing data. So isNA. So if you want to identify the missing data, missing data across our data frame, we can do that, and we can be able to see that from this method. But we may not be able to. This may not be an appropriate method because if you have a lot of data, you may not be able to see. So any place that you see there's a true means there's a missing value there. But to further again get the column that have missing data, we can use column sums. Then again we use the same isNA function and pass the dt data frame function, the data frame, not data frame function, just the data frame to isNA, is.na, and then we can be able to see the columns that have missing values, which is name and age. So we can also be able to drop rows containing missing values, and we use the na.omit for dt. So you'll note that we will only have 2 rows because there's one row that has missing values. So this is the end. Note that we can use the same method if we had loaded a bigger data set. Here we just wanted a data set that had missing values. We can also impute missing values in a column using a number. We can use maybe a number. So if you want maybe some arbitrary value such as 99, we can be able to replace that for age. Maybe for age, because age had false here, we can use a number, maybe an arbitrary value that is just set. Maybe 99 is what makes sense based on our expertise. We can do that as well here. Alternatively, we can also do mean or median or mode, etc. So to impute the missing values maybe for a particular column, we can decide to first of all define the column that we want to work with, and then use isNA function to be able to specify that for whatever, or specify where we want to specify the missing values, and then we use dt compound age to specify the column that we want to identify the missing values for, and then we want to replace the missing values within the age column with 99, as you can see here. So we are performing imputation by just arbitrary imputation generally. That's what you can see here. Alternatively, we could have also wanted to have done, maybe instead of 99, we could have done something like should I put it, maybe a mean. So a mean would have been, instead of specifying 99 here, we'd have found the mean. We use a mean function to find the mean of dt.age, and then we specify here we don't want to include the mean of the missing value. In the mean operation, we don't want to include the missing values to calculate the mean by specifying na.rm, and that would give us the mean. But now here the problem is that we already had imputed that, so we can just simply reload this particular cell and then rerun this. So, and to get 49, which is the mean of this and this. So there's a whole lot. There are many techniques that we can use for determining the mean of a particular, the mean generally. And We are going to learn that in a separate workshop on how to work with to how to perform imputation using various techniques. We already have a course on handling missing data with Python. You can always check it out if you want. Okay, so work on the challenges and then we can continue. Finding and dealing with outliers. So let's load this new data set that will contain just some data that we are going to be working with. Right, that's what we have. Then we can determine the number of records and variables, that and that. These are 1,704 records and 6 columns, 6 variables. To be able to define outliers, so we can decide to define outliers as those values that lie outside a certain percentile of the data that we have. So assuming that we had a data in one particular variable, and that particular variable had maybe records from 1 to 100, and we might decide to say that we might realize that maybe a majority of those records actually lie between 25 and 75. So we can define that any record that lies outside, or like, from 75 to 100 or from 25 to 0 is actually an outlier. So those are just percentiles that we can be able to create the idea of percentiles to define what outliers are. And we can do that with any sort of variable that we have in mind, only that we need to define the quartiles, or the actual, not quartiles, the actual percentiles for those particular, the variables that we are working with. So for example, if we want to define outliers as those records that have values that have GDP cap values that lie outside the 75th percentile or below the 25th percentile, then we can use this method by first of all defining those quantiles, not those percentiles, using using the quantile function. So you'll be able to see that our lower bound that's is 1,202.06, and our upper bound is what is shown there. Once we have done that, we can be able to get those outlier values by simply using the which function. So we can be able to define we can be able to define that any record that lies for any GDP per cap record. This is a column in DF that lies below the lower bound, below this value, or lies greater than the upper bound, should be treated as an outlier. And we can be able to retrieve those values as actually as shown. So those values will be the values, not records, actually. The values for GDP cap are what we're actually going to retrieve in this case, and we're going to store them inside outlier values, and you're going to see them, which you see here. And then once we have done that, we can then decide to get those outlier values. But in our case here, what outlier values? So in our case here, you might also notice that we have these values, the indexes. Actually, we are getting the indexes for those particular values. And once we do that, we can get them by simply the records for those values by simply using this method df. Then we specify the indices and indexes, and we can be able to preview them as shown. These are the records with outlier values based on GDP per cap. So it's probably they have little, or if you go to 86 or 85, they have, okay, they have a lot more. But generally, those are outlier values based on that. Not sure why you're getting that here. So see that are more than 75th percentile or below. So if we want to get those values which are not outliers, we can just get their indexes and then later get the records that are not outliers as shown. All right, work on the challenges and then we continue with merging. So moving on with merging, importing our data set, we can first of all import the data set that we want to merge. The two data sets we have, join dataset 1, join dataset 2. Let's preview the first join dataset 1, which has the following data: kingdom, turn, class, order, family. It looks like maybe flowers or something. Could be just some plant species or tree species. And then this is the first one. Let's preview the second one. Comment that. Click on this arrow to just go to the right. So sign name. So sign name seems to be the common column. So because in in JNDF1, we have sign name is a common column. So to be able to combine both tables based on that column, we can use the left join method. So first of all, we define the data frame that we want to, the first data frame that we want to join. And this is the first data frame, JNDF1. And then we use a pipe operator to be able to specify the operation that we want to perform on this particular first data frame, and we want to join it using this method called left join. Want to join it we want to join this df1 to this JNF df2 by this particular column that we specify here on the left hand side for the first column. Well, on the first column, on the column that we want for JNF for the first data frame is the sign name. And we also define the column in the second column in df2 is also sign name, and that's basically it. That's what we get. And we can also store it somewhere in maybe another variable that we can use for analysis. Right, work on the challenges, and then let's continue with our last section. All right, after you verified the solutions, then we can now continue concatenating two columns. So maybe sometimes we might have columns that we want to combine. So combine maybe name and age columns, or maybe country and city to just have a region, or different columns. So, or maybe first name and last name, so that we have one name, maybe full name column. So to be able to do that, we can use this method that we have here. So we can first of all, we load the dataset that we want to work with, concat df, and we can be able to preview it, just understand what we have. This is what we have, this is a column. Then we can be able to combine name as well as the age column, so that we can just have name age, could be something useful. And then we can do something with it. So concatenate is the variable that where we want to store the final result, and we define the concat df function that we want to perform our concatenation operation on. Then use the pipe operator to specify that we now want to perform some operation. By the way, we are using dplyr in this situation when we see a pipe operator. And then we specify the function that we want to apply to this particular data frame, which is unite. Then the new name of the column that we want to create, and then we specify which columns we want to combine. By the way, this is the second parameter, and then we use what to separate those two particular values in that new column, and we preview now the column that we finally have. So name age has this, what you see here, and you'll note that in this situation we are uniting, we are combining name and age columns, and then those columns will be deleted automatically. There's a mutate function. Aside from unite, we can use a mutate. It's called a mutate function, where we can be able to we can actually also perform the same operation, but we can still have those column names that we had deleted earlier. So you can look into that operation or that function if you want later. And that's it. You can just work on the challenge, and then we can continue to the next steps. Now, moving to the next steps, as part of just continuing your learning journey, we have provided this project that you can work on that will help you to be able to achieve those skills that you have learned so far. And the idea is that you're going to be able to put into practice the data wrangling skills to just ensure that you have a good data set that can be able to be used for some recommendations. So work on this challenge. We've provided a solution notebook or workbook that you can download and be able to also upload it and be able to work on it as well. By the way, before I even just give you, before I end, before we close this, just to show you something else that might be useful in your project. When you want to work on a project, you can just go to File, the very top, New File, then you create a new R Markdown file. Just click on that, name it the way you want, the project, and then your name. You want, this is our default output format, just say okay, and it's going to open a new tab, the very top. And you can always save it as in your project as a maybe project. Save it project, and it will save it. Once you save it, you should save here. You should see a project over here. And this is the notebook that you can be able to work with, and you can delete the content that you see here, and start afresh by clicking on visual, and from there you can now be able to work, and you can write your information, your analysis. If you want to insert maybe some code section, you can put a /, and then you can say R code chunk, and then you can be able to insert R code chunk, as you can see here, and you can write your code in there, provide some observations, and then insert another chunk. Or if that method for / doesn't work, there's also an insert functionality here, feature that will allow you to be able to insert, maybe it's an executable cell, which is R. You can also insert it, and you can be able to work. Once you're done, you save your work, and then you just export it by simply clicking on, let me just even expand this. You can just click on the project that you want. If it's this one, then you go to more, then export, and you should be able to download it, and you can upload it on our platform so that you get a certificate if you want. But the idea is just to help you to just put into practice those skills that we have learned so far, and hopefully you have learned already. You have been able to achieve a bit in those 1.5 hours or so, and are ready to now continue with this learning journey. There are of course other courses that I would recommend for that come after this particular course, that could be performing data analysis with R, or data visualization, or handling missing data. Those are just different courses that you can take depending whatever area of expertise that you work in. Maybe you want to use those skills in that area, so that is something. But just try as much as you can to be consistent in that journey. All right, all the best in your learning journey, and see you in the next course. Bye bye.